Let's look at example 1 of area 10, which is this mostly of research methods in terms of data collection, analysis methods, and stuff like that. So here, this is actually on research methods, and this is area 10 of the problem solving and data analysis. So let's look at this table. The table looks at students' sleep habit. You guys don't sleep a lot, so we have a random sample of students in 2 different universities were surveyed for their sleep habit. The results are shown in a table. Now, if you look at the results, we have University A, University B, we have average sleep, median sleep, most sleep, and standard deviation. Now, this is very interesting. If you don't know what standard deviation is always measured as a plus or minus because it measures how far the data deviates from each other generally. So if you have a high standard deviation, that means the data deviates, the deviation is more, you have more deviation, it is not clustered. So for instance, this kind of data here, for instance, will have a wider standard deviation compared to this data set. If I have data that all clustered like this, then if standard deviation here is 1, standard deviation here may be 3 because you are trying to measure the center of the data and how far the other data deviates. So here, if the center is here, then technically almost all of them are. If the data, they are all, if you have the same data set, 1, 1, 1, 1, then the standard deviation is equal to 0. But once you move away from each individual data, then you begin to increase the spread, and that is what the standard deviation measure. It measures the spread of variability of your data. So let's move on and look at the question. Say, which of the following statement is supported by the information in the table? Now also look how carefully they are structuring this problem supported by the data, all right, information on the table, because it is very dangerous to just use information coming from a sample and make it a general solution for the whole population. It's dangerous. You don't do that. So you always have to be careful as to the structure of your statement. So what you're going to do here is the first one is the hours of sleep per night varies more among students in University A than university. That means the standard deviation. What you are saying here, the standard deviation of A is bigger than that of B. Is that true? Yes. This is 3. This is 1. So we know this is true. We can actually see from the data the standard deviation. There's more variability in A than in B. So that one is true. B. More students attend University B than University A. As you can tell from the sample, they did not tell us how many samples they picked. All we know is the mean and the median. So we cannot tell how many samples even they selected for A and how many they selected for B, not alone how many students are in A and B. So this completely, we can determine that. More than half the students at University B get 7 hours of study. This is nonsense because, I mean, we don't even know the number of students involved, so we can't say that. Half the students at University A get 6 hours of. So anything that is the actual number of students in the school is simply is not discernible from the data that we have because the data is scanty. They didn't even give us a sample size, not alone the population. So in this particular case, your best answer is choice A, which is very clear because the data actually tells you that the variance is bigger in A.